Okay, hello everybody. So this video goes over for this is again AWC's CHM-151 General Chemistry 1, the quiz 4 review and mid-semester review. We're going to cover thermochemistry. Okay, so we're just looking at this area of the handout. And this is about specific heat capacity. If 2.89 kilojoules change the temperature of a substance 4.23 decagrams by 22.7 degrees Celsius, what is the substance's specific heat capacity? So let's first start out with the specific heat capacity equation. That's plus or minus Q is equal to mass times specific heat capacity times change in temperature. Mass would be in grams. Specific heat capacity, so let me write that here, grams. This is specific heat capacity is joules per grams degrees Celsius, and temperature is degrees Celsius. Okay, so if we know that, let's first convert 4.23 decagrams into grams. So I'm going to put decagrams on the bottom, grams on the top. There's 10 grams in 1 decagram. So let's multiply the 4.23 times 10. We get 42.3 grams. Okay. We also want to convert this from kilojoules into joules. So we have 2.89 kilojoules. So we multiply times 1,000 joules per 1 kilojoule. 2.89 times 1,000. What we get is 2890 joules. This is positive, so we know we're going to have a positive Q, our energy in joules. We also take our temperature, and we know that it's changed by. Not only do we know that this is given in a positive number, so we're going to keep this as 22.7, but we have a positive Q, so our temperature has to be positive also. So if we were going to plug this in, we would have 2890 joules is equal to 42.3 grams times our unknown specific heat capacity times 22.7 degrees Celsius. So we can multiply 42.3 times 22.7 and we get 2890 joules is equal to 960.21 joules times degrees Celsius times C. We'll divide this by 960.21 again grams times degrees Celsius. 960.21 grams degrees Celsius. And our answer then, 2890 divided by 960.21 is equal to 3.01 joules per grams degrees Celsius is equal to our specific heat capacity of this substance. Okay, so moving on, it's a thing of true or false questions. I'm going to give you some time to read it. So after reading it and thinking about it, we find that the answer to the first one, or the statement, is false. The second one is true. The third one is false. And the last one is true. Now let's go on to this one. What is the equation for molar enthalpy, specific enthalpy, and enthalpic density? Well, molar enthalpy is joules or kilojoules per mole. Specific enthalpy is joules per gram. And enthalpic density is equal to joules per liter. We could describe, and by the way, I just want to point out molar enthalpy has a couple of different names. It's also like the enthalpy of vaporization and delta H vaporization. But let's describe these in our own words. This, we would say energy per mole, energy per mass for specific enthalpy, and energy per volume for enthalpic density. So that concludes this part of thermochemistry, the quiz 4 review and mid-semester review.